Hey guys, good evening. I hope I'm pretty much audible. So do let me know if I'm audible and visible, guys. Very good evening to one and all present in our chat today. So we are into our playlist of data analysis in 3 weeks, and objective of today's discussion is on Seaborn. And you already know that we have been doing quite a lot of good things in Seaborn. And today we'll be talking about categorical plots, right? So we have been discussing about numeric to numeric analysis in bivariate, and we also saw some of the categorical plots. So yesterday we were talking about how we can use different swarm plot and strip plot, but again today we'll go a bit deep in the categorical plots, and we see how exactly we can be using that. Great. Hi Manav, thank you so much for confirming. Great. Good evening and welcome you all in today's discussion. So again, just a quick update. Good evening, everyone. I hope you guys have started joining in. So we are into our data analysis into 3 weeks. That's our playlist name, and we'll be talking about Seaborn, talking in deep in terms of categorical plots. That's going to be our agenda for today's discussion. Great. So, as always, anybody is having any concerns, any doubts regarding whatsoever topic we have discussed so far, be it from the available set of questions and be it from the topics like list, tuples, dictionaries, Python function, lambda functions, anything guys, anything. So if you have any questions regarding any of the topics, so just do let me know. We'll try to take that, okay? And this is pretty much a live session, okay? So please feel free to put up your question in the chat and utilize the time. So that's what we'll be doing, right? So that's what pretty much the agenda is, and try to make the class interactive. I have always been telling that, right? So please ask as many questions as we can. And the important thing again in the data analysis, that too in visualization, is not only to plot the graphs. Now once you have plotted the graph, how to read them, right? So what is the meaning of what we are getting in the data? That is something also which is very important, okay? So do keep a note of that, and we'll definitely be talking about how we can take the things up. Cool. So before starting into our discussion today, I'll introduce myself. My name is Arpit Jain, and I'm a lead data scientist myself. I have been into industry for almost 9 years and into multiple domains, be it finance, automobile, manufacturing, cloud, telecommunications. So I've been into multiple domains, and I've seen in my experience how somewhat industry works in different domains in data science field. And in fact, that's the beauty of being in data science. You kind of get that invisible immunity, but that always helps. And also, I'm a motivational speaker, so I take industry sessions. I talk to students regarding their job, career, placements, anything. So any questions regarding data science, when to switch, how to study, what to study, which companies to apply, all those are very generic questions, guys. And if you have those questions, please feel free to ask me. Although these are generic questions, answers might vary from person to person, right? Depending on the profile. So do put up your questions. Let's try to talk, and we can definitely get going, right? Meanwhile, I think we have a question from Vasanta. Good evening. Thank you for joining in. You have a doubt, okay? Every time we need to open sns.accessstyle, how to know which one is true and which one is false? Why we use sns.setContext? Okay, good questions. So sns.accessstyle, as I said, I'll show it to you also. So if you do sns.accessstyle, basically you'll get the list of parameters or the kind of arguments which you can use for access style. There are multiple of such access style functions. So we saw font color, we saw the grid color, we saw backend color, the font. There are a lot of options, tick mark, right? So I have shown you the list, right? So if you simply do sns.accessstyle, you'll get the list of all the available parameters which you can give, right? Also, the default values are given. I'll show it to you also. I'll come to the contents and I'll show it to you. So the default values are given. So in the default values, you will see, for example, if it is written true, for say, I'll show it to you. So if it is true, that's the default value. You can change it to false. Likewise, all the default values are by default given in the parameters, and we can change it to whatever we want. Okay. To second question, SNS context. So set context is basically used for your scaling. So as I said, we have three things in three things in aesthetics, right? One is your theme, which is your styling part. So that's where your theme and the axis theme comes into place. The second is my scaling. So the set context is used for scaling. So scaling of your x and the y axes. So here also we have 4 to 5 default options. So we have poster, we have notebook, we have text. So remember, right? So based on that, we change the scaling of my x and the y axis. So that is the reason why, that is why it is used as an context, to change the scale of my x and y axis. Okay. And then we have another third thing is color. So we have already seen how to use color and when to use color. So that's pretty much it. But again, let's proceed. Good question, Vasanta. Thank you so much, and thank you so much for asking that. Likewise, any other questions, please feel free to ask. And I also show it to you what I meant when I said axis style, right? True, false. I'll show that to you actually. Just give me a minute. Let me pull up the content slide. I hope my screen is visible, right? So I'll show it to you. What did I mean when I say axis style? Yeah, look at this. So if I do sns.axis style, it'll give me the list of all the available options I have in the axis style. Okay, all the available options I have. So here you can see my edge color, I can see face color, I can see grid, I can see axis below, label color. So you can see here, right? So axis.grid is equal to true. It is written here, right? So the default value of axis.grid is true, but I can obviously make this to false, right? And likewise, all the default numbers for text color, xtick color, direction is out by default, and then we have here patch force edge color, that is true. And then so all of the values, and then see Arial is a default font in this case. So font and then font family is sans serif. So pretty much everything is by default also given. Even if you don't give axis style, you will still get the graph, right? That is where it uses the default values. Okay, so that is where it uses the default values, and this is what we have. Okay, so default values is what we have, and this is how it is used. So but again, we can obviously change it depending on our usages. Cool. So proceeding to the categorical plots. So here we discussed yesterday about swarm plot and strip plot, right? So very simple plots. So strip plot and the swarm plot. So strip plot and swarm plot is giving me the interaction between my categorical and my numerical data. Okay, so this in swarm plot and strip plot, one column mandatorily has to be a categorical column. Okay, so for example here we have taken x-axis as my category column. So I have the category here, my species, so which is Setosa, versicolor and virginica, right? And on the y-axis we are plotting the graph with petal length, right? And what we are using here, strip plot, right? So strip plot. So here all the points, so all the points which is present for these data, right? It is being plotted as a dot point. So you can see all the dots is like one single unit of my observation, right? So that's what it is. So also one thing you can definitely infer from this is it's a clear distinction of my data point. So there is a very clear distinction. So the range of my values is very distinct, right? And also I could see that it's a progressive increase, right? So the Setosa are the species where the petal length is the minimum, and so virginica is the one where the species are of larger petal length. So it's very clear inferences from these, right? One thing which we could see here is the dots are getting overlapped, right? So we cannot actually count the number of observations. Rather, it's more like giving me appearance, more like a density kind of a thing. So here I can see all the dark shaded, so density is higher here. This is sparse, so I could see majority are here and then minority are spread out. Likewise here, almost everything is majority, so it's concentrated on a smaller area, right? So this is what we can infer. So on the contrary, we have swarm plot. So this is another alternative to my strip plot. Almost similar information we are getting. Only one difference here. Instead of having all the points, overlapped, all the dot points getting overlapped, here in swarm plot, we get all the points plotted separately. So we can literally count the number of dots also, right? And now here, whenever there is a larger spread, so whenever the number of data points are more, right? So the horizontal breadth will be more. So of those data points, horizontal breadth will be more. So that's how it is. Right, so that's what it shows, the swarm plot, difference between swarm plot and strip plot. Okay. Now proceeding ahead, we also talked about distribution of observation. So now we'll be doing distribution of my observation within each category. Okay. So here now we are trying to understand distribution of values within each category. Now let's look at that. Okay. So for that, the very famous graph is a box plot. It's a very famous graph. Box plot is generally very oftenly used. Okay. So box plot is one of the very convenient ways to visualize the distribution of data through their quartiles. Okay, so what do I mean by quartile? So 25th quartile, 50th quartile, and then 75th quartile. So basically first quartile, second quartile, third quartile, so percentile of the values, right? So here we are trying to visualize the data through their quartiles. Okay. So what do I mean here is box plot usually has the vertical lines extending from the boxes which are termed as whiskers. So now if this is what we have, so here you can see these whiskers, right? So these whiskers. So this is my top and the bottom whiskers. So which is like vertical lines extending from the boxes. So here these whiskers indicate variability outside the upper and the lower quartiles. So what do I mean here? So box plot are also termed as box and the whisker plot. Why? Because I have a box in between, then I have the whiskers on top and the on the bottom side, right? So any outliers which is there in the data beyond, so any points which is getting plotted beyond the whiskers are actually termed as my outliers. Got it? So this is what my outlier is. So anybody is having any understanding of what the box plot talks about? So anybody is having anything which you know about box plot, just that quickly update in the chat. Anybody is having any understanding of box plot? Quickly guys, anybody is having any understanding of box plot? Okay. So I'll tell you, I understand it's pretty much the first time for you guys, so it's fine. So I'll tell you how exactly box plot works, okay? So in box plot, what you can see here is the box, okay? So we have a central box and then we have the lines, okay? So here, important thing to understand is we have two things. We talk about the quartiles here and then we talk about IQR, or it's come as inter quartile range. Okay, so interquartile range is nothing but my 75th quartile minus 25th quartile, right? So nothing but your 50% of the data. So 50% of distribution, correct? That's what we have here. And now, so this is what IQR means. Now, so this box here, the lower side of my box, so on the box plot, I have box, right? So for the box, lower side is 25th quartile and upper side is 75th quartile, okay? Now, after this, we have what? We have whiskers. So top horizontal line and the bottom horizontal line. So whiskers. What are whiskers? So whiskers are nothing but, again we have lower and upper. So for the lower, it's basically my Q1 or 25th quartile, right? Minus 1.5 times of my IQ. So this is what this means, okay? So 25th quartile, this is my Q1 value minus 1.5 times the IQR, okay? That's my lower whisker. This is what the plot means here, okay? And now for the upper is Q3 plus my 1.5 times of my IQR, okay? So this is what these points mean, okay? So the first line, second line, third line, fourth line. So this is what we have. So the lower line is my lower IQR, correct? My lower IQR value. and this is what we have for the data, and then we have the other values. Okay, and also we have the middle line here, right? So our line between the box, so that is also called, that is a median actually. So within the box I have a middle line, right? So middle line is nothing but median. Okay, so middle line is nothing but my median of my values. Okay, so I have basically in this box plot I have 5 lines, 1, 2, 3, 4 and 5. So in the order, this is my Q1 minus 1.5 times of IQR, the second is 25%, so Q1, third is median, fourth is Q3, and the fifth is Q3 plus 1.5 times of IQR. Okay, so now any point which is either below my below the points of my whiskers are termed as outliers. Okay, this is how the data is getting plotted in box plot. Okay, just give me a minute. So this is what we have for the box. Now how we are plotting it, it's very simple. Now look at this, it is very simple. So we are calling the function box plot. Okay, so we are calling the function box plot here, and in the box plot we are passing the x as x-axis, so nothing but my categorical data, and then the y of petal length. So what we are trying to identify here is how the data is distributed per category, right? So I wanted to understand how the distribution of my petal length is, which is nothing but a numerical column, but also I wanted to understand how it is varying for each of my species. And what are my species? A categorical column, right? So this is what we are trying to see from the box plot. Make sense? This is what we have in the box plot. Cool. Pretty simple actually. So now here from this box plot, what we are observing is, so just look at this. So for the Virginica, the entire box plot is quite big, right? So I can see the whiskers are pretty spread out, and the box is also a little bigger compared to Setosa. Setosa, it's a very confined box. I mean, it's almost, so the median line is almost invisible. And also the quartile values 1.5 plus and minus Q1 and Q3 and Q1 are also almost touching the boxes, right? So this shows that my Setosa value are pretty confined, right? So they are concentrated on a smaller area. This is what it means. And in Virginica, where we could see that the values, so the boxes are big, and also the whiskers are pretty much visible. So we can say that the data are more spread out, right? But now since in Setosa, since the overall data points are very much confined, in such cases outliers are more in Setosa, because even the smaller change will lead to an outlier, because I have a very smaller range of values. Even when the range is smaller, any value which is beyond that range will be a outlier for me, right? So that is the reason why, even though the range is very small in Setosa, the outliers are the max. Right, you can see this. I have, even on the top side we have outlier, or on the bottom side we can see some outliers here, right? On the contrary, Virginica has no outlier, because before itself it has, the range is quite high, right? So data is already spread out, right? So that is what very clear distinction we can see from this graph. And also versicolor has only one outlier, which is on the lower side of my graph, so lower side of my data point, right? So this is what this graph says. Anybody is having any concerns in understanding this graph, guys? Just a quick yes or no. Anybody is having any concern in understanding this graph? Do let me know. So understanding of my graph is very important, as I have always said. So if people is having any trouble in understanding the graph, do let me know, guys. I hope it is pretty much clear. This graph is pretty much clear, right? Cool. Let's proceed then. Same thing. What I'm doing here is, now look at this. I'm loading the data tips here, right? So initially also I was working with the data set tips, where I have what? So I have the data of my tips, my bill amount, the smoker, gender, we all saw that data, right? So now on this, we are trying to observe how the total bill is spread out based on the day, right? Very interesting thing. So now we are trying to see on each of the days how my total bill is spreading out. So this is what I want to see, right? Now, very interestingly, can you see one thing here? So I plotted this graph. It's a box plot pretty much. Now what I'm seeing is, here the values are somewhat increasing. So you can see this, the overall range is pretty much increasing as we go ahead. So Thursday and Fridays are pretty much low, and on the weekend, Saturdays, Sundays are pretty much high, and on Saturdays it's the max, right? So the range is pretty much max. And also the overall box size is also very much high compared to, it's comparatively bigger compared to the weekdays, right? So weekends and the weekdays are pretty distinctive here. So weekdays I could see the smaller ranges of values, but on the weekends I could see the bigger ranges, right? But also interestingly, I saw that on Thursday there are some certain outliers based on that day's distribution, right? So even on Thursday we have some good number of outliers. And also you remember on Saturday we saw some big outliers where the bill amount was very high. So we saw all those 3-4 points, right? So that's what the points are, where the bill amounts are very high on Saturdays, right? And also we could see the values is fanning out on the lower side as well. So the data is pretty much spread out over the weekends, right? So we could see that even the values are on the lower side as well on Saturdays. So Saturdays and Sundays are very distinctive compared to my weekdays, right? It's very, very distinct graphs. So we are able to clearly identify the differences in my trend. So on weekdays, the ranges are very very low comparatively. Likewise for the weekends, the data is quite spread out, right? And also a prominent outliers on both the Saturdays and Sundays. Clear, guys? Any questions in this? Anything if you're not able to understand? Cool. So on the same graph, as I said, we have the argument hue, right? So hue can be added pretty much in almost every graph, as I've told you, right? So hue is it's a universal kind of an argument. You can add it anywhere, adding as the third dimension to my data. So we have been looking at this, right? So the same thing we're trying to do here. So we are adding the component hue. So what is hue here? Hue is nothing but adding the third dimension to my graph. So here we are on the same data, the same day and my total bill. I'm trying to see how the bills are changing respective to my gender, right? So my male and female, how exactly the bills are changing. Now just look at this, guys. So you can see again a very, very, very distinctive differences, right? So you can see this. Interestingly, on the weekends, the females are paying on a lower side, right? But again, they are paying equally good. So even I think I would say higher on Saturdays when it is, by default seen, maybe males are spending more on the Saturdays. That is not true. So you can see this in this graph. The females are spending maybe even higher than the males, right? So you can see this, the box size of the Q3 value is higher than the Q3 value of my males, right? So this is how it is giving me a better, broader picture in terms of how my overall data looks like, right? This is the power of data visualization. So some things which you cannot just get by seeing the numbers, you have to visualize this in terms of graph. Now this graph is very clear. It is giving me a very clear, distinctive picture, right? I'm pretty much seeing that. So in the males, I have the outliers. Females are generally very evenly spread out. So they have very minimalistic outliers, right? So, and then also I could see that on the weekends, they are paying lesser comparatively to males, but on the weekends, they are paying almost equal and maybe sometimes higher also compared to males, right? So this is what we have, guys. So we can add hue also pretty much on this box plot like this. Okay. Now proceeding ahead, we have another interesting plot, which is violin plot. Again, giving the same information. Okay. So if you look at this graph, and this graph is giving me almost same information. I'll just tell you how to read this information. So there is something extra in this, which I'll tell you. Okay. So apart from giving the distribution, so this is also giving me the distribution, right? Giving me the outliers, where the outliers are. So this is also giving me that information, how the data is spread, but also giving me the information of density. Density means where the points are higher. So likewise, so we had the strip plot, swarm plot, right? Where we were able to see that, okay, where the values are high, the density is more, the fanning is more, the spread, the breadth is more, right? The same information we are trying to get in violin plot also. So violin plot is giving me two information, guys. Two very important information. One is data spread, data distribution. The second is data density as well. Okay. So density and distribution, both you are getting from violin plot. Is a very interesting and very popular graph, violin plot. Okay. So now how to read this graph, I'll tell you. This is again very important, guys. So be very attentive and ask me any questions if you have regarding to reading up the graphs. Okay. So here, same data. Okay. So same thing. X is day and Y is my total bill. And instead of box, I'm plotting a violin plot. Okay. So in this violin plot, I'm seeing that on the day wise, Thursday, Friday, Saturdays, and Sundays, I'm plotting my individual graphs here. Okay. So now what I can see is, so for each of my days, how my bills are spread out, how my bill is spreading out. Okay. So now you can see this on Thursday, this is how my data looks like. So you can see this bulge part, right? So this bulge part is showing that there is majority of my data points lying in this area. So on Thursday, majority of my bills is between the range 10 and 20. Clear? So the majority of my bills is in the range of 10 and 20 on Thursday. Likewise, even on Friday, it's in the between 10 and 20. So almost similar. So even on Saturdays, even on Sundays, the majority bill amount is between 10 and 20 only. But still there's a difference. Now we can see another thing. So we can see some peak. So top peak. So we can see this. Compare this peak on Thursday and the peak on Saturday. So Saturday's peak is more, I would say, more thinner, right? It is elongated peak, right? So now this shows that on Saturday we have the data pretty much the outlier. So if the peak is going thin and thin, that shows that there are many outliers in that area. Okay, so the number of data points are less, but the range is high. So you can see this. So basically at this point still there is some data point, but there are very less data points compared to what we have here. So this means that this area is somewhat an outlier for me compared to my general distribution, right? So this is where I'm saying, although comparatively to my other days, Saturdays is having some higher data points or potentially an outlier, but still my majority of my data points are still lying between the values 10 and 20 for each of my days. Got it? So this is what you are getting the information out of my violin plot. So here, two things. So the the wider portion of my violin, so wider portion means this area, okay? So where the bulge is. So the wider portion of violin plot indicates the higher density, okay? And the narrow region represents relatively lower density. So narrow region represents a relatively lower density, okay? So the IQR range in the box plot and the high density portion in KDE fall in the same region for each category of the violin plot, okay? So basically giving me the density of my individual plots. Same thing here as well. I can add hue. So hue is nothing but the third dimension. So I have added the same thing based on the gender, my male and female. I'm trying to find out how the bills are spread out, right? Again, very distinctive features. You can see this, right? So look at this. So this violin is pretty much looking like a leaf, right? So data is pretty much evenly spread out for my males. But contrary on the females, also we could see that the value of my maximum is going maximum to 25. But for the male, maximum is 50, just the double of my data points what we have on Fridays. So Fridays, males have the maximum outlier, and also the data is evenly spread out. So the bills are varying almost equally between say 0 to 40, 45. So the data is almost equally spreading out. But again, the females paying the bill is pretty short, so that the value is ranging between 0 to 25, only just the half of what we have in the original. And also there is a huge bulge around 10 to 15 range, right? So there's a huge bulge. So the number of data points are still concentrated on the lower side itself, right? Also on Thursday, I could see a very significant peak in terms of female. So on the female, so somebody was paying a higher amount in the lower area. So I could see the peak is very thin, very thin. So the number of data points is very less, right? So there's a potential outlier on the female section on Thursday who has paid a very high bill compared to other days, right? So that's what we can see from here. Cool. And also we observed on Saturdays we have almost the equal payments being happening, and also the bulge is somewhere around between 10 to 25. So that's what the range is, right? So that's what the value. And also we could see the bulge part is comparatively higher on weekends than compared to on Thursdays, right? So slightly higher. So on the weekdays is somewhere between 10 to 20, but on the weekends it's between 15 to 25 to 30, I would say. So like almost $5-10 difference in terms of average bill pay. Not I would say average, like majority bill pay in compared to my weekdays, right? So weekends majority bill pay amount is slightly $5 or $10 higher, right? So this is again the kind of inference which you have to look out from this graph. Okay. So now this same graph can actually be merged. Okay, so now here the same graph can be merged. So if we have the option of the class in my hue is only 2. So for example, I have only 2 classes, male and female, right? So if the hue class is only 2, I can merge these 2 violins also, okay, in the same graph. So instead of 2 separate violins, I can make one single violin. Okay, so I can do that by what? So we have another argument called as split. Okay, so if we add split is equal to true, we can make these 2 different violins into single violin. So now look at this. So the same graph here now converted into like this. So on the left side we have male, and the right side we have female. So now it is even better comparison, right? So it is even better comparison. Now you can see this. So the male's peak is somewhere between 10 to 20, right? Whereas female peak is slightly lower, between 8 to 15, I would say, right? So that's my peak for my females, right? So again, we have a very distinctive comparison between my males and females in terms of days and how we're gonna make the payments for the bills. Cool. Again, one interesting graph. So we can pretty much use the functionality split is equal to true. So by using this split is equal to true, we can have the same hue only if, again, the condition is the hue class should be only 2. Okay, so the variable which is getting used in hue should be having only 2 classes, not more than that. So then we can merge the 2 violins. Cool. Clear, guys? Any questions? Anything if you're not able to understand, just do let me know. Please do let me know if you're not able to understand anything. Guys, is this getting clear? Quickly, guys, just to let me know if this is clear. Just a quick yes or no. Cool, great. So I hope you guys are able to understand the concepts pretty well. And this is simple only. This is nothing fancy, but again, one need to at least understand what is the importance of these graphs and how to read it. Okay. Cool. Now, after these categorical inferences, we'll talk about the statistical estimation in terms of graph. Okay. So how we can look for statistical estimation. So estimation of central limit theorem. So more like a bell curve we were talking about, right? So how we can find out those things in graphs. So we'll look at that. So the first such interaction can be plotted using a bar plot. Okay, so bar plot is a relationship between a categorical variable and a continuous variable. So the like way we are plotting the swarm strip, right? So where we have categorical to numerical. So that's what pretty much bar plot also do, but we'll see how exactly we're going to use it. Okay, so here the data is represented pretty much in a rectangular bars, the way we were doing in the hist plot also, right? So the dist plot. So here we also have the bars, pretty much the rectangular bars, where the length of the bar represents the portion of the data in that category. So here, instead of a kind of a density, we want to represent a frequency. Now look at this, how exactly we're going to be doing that. So now here what I've done is I've loaded a new data set, which is the Titanic data set. Okay, so Titanic is again a very common data set used for your day-to-day analysis purpose. So pretty interesting columns here. So we have column as survived, 0 and 1. So 0 means dead, 1 is yes. So and then the class of my passenger class 3 to 1. I have male and female here. Age of the passenger, I don't know what is this. And then we have fare, we have embarked, and then we have class, man and women, adult male, true or false, deck, right? And then we have embarked, town, alive, something like that, right? So all of these things are there in terms of data. So now let's try to plot it. Okay. Now look at this. So in bar plot, what we are trying to do is we are trying to see how exactly my density of my information available in terms of my data. So here, instead of counting the exact values, right? So instead of counting the kind of a frequency for my data, frequency means the actual count of my data, the way we were doing in the box plot, in the dist plot. Here we're trying to understand the kind of density. So how the distribution kind of a thing of the values are. So here what I've done is, so I've plotted the same graph bar plot between x and the y axis, and we have added the column hue. Hue is nothing but my class. So I'm trying to see how the survival is changing. So how the survival is changing based on my males and females depending on each of my class. Okay. So now for the males, you can see that the blue is first class, second class, third class. So the first class are saved the maximum times. Almost 40% of the males survived are from first class, and then likewise we have the second class, we have almost 20%, and then the almost I would say this is what the density shows for me. Likewise for the female, female is again pretty much the maximum in terms of first class and the second class and the third class. But also you can see that comparatively for the males and the females, the bars for female is very high, right? So female survival rate is still very high compared to my male survival rate, right? That's also one thing which we have to look forward to. Cool. So this is what we have in terms of my data here. Now how to exactly add some more interesting information. So here again in the bar plot we have n number of arguments available, so we can keep on adding any n number of different things in this. Okay, so we can add something. So I've tried to add few more interesting things. So I tried to add palette. So palette means color, so we can change the color. So we've added purple, red, so PURD. So there's nothing but the palette which I've used here. Order, we have changed the order, so male and female, so male first then female second, and then we have the cap size of 0.05, we have the saturation level as 1, and then we have the error color as red. So I'm also plotting the error, so nothing but my confidence interval is standard deviation, and also I'm plotting the red color as my error color, and error width is 2, so this is the width of my line is basically 2 here. So I'm trying to add more parameters, again more hyperparameters, very much possible in terms of how we can think of the plotting here. Okay, so again, let's not get confused by different options we have. So it's pretty simple. Again, I'm not doing anything fancy. I'm just trying to show you what are still different options if we have. If we simply do kind of a just a shift enter within this graph itself, you should be able to get the options we have in terms of arguments. So it's not working. Okay, just a minute. Just let me load this up. Import Seaborn as SNS. Okay, cool. So now, yeah. So now I've just inside the parentheses I've done shift enter, and when you do shift enter, you will get the what arguments you can provide on this, a little documentation kind of a thing. So you have n number of things: hue, data, order. We have CI, confidence interval. We have units. We have seed, palette, saturation, error color, error width. So what? And again, if you don't know the meaning of these hyperparameters, it's pretty fine. Even I would say maximum of the people still don't know everything in the hyperparameter, right? So that is the reason why we have this documentation. Just do a shift enter, and this dialog box will open, and just do a plus here. It'll open up the entire doc, right? And then for each of my hyperparameters, the definition is also given. So the data here, the order, estimator, what is estimator, then we have CI, what is CI, right? And also at the end, you will see some examples also. So how to write these things. So you can see here like this. So bar plot, you can see how to exactly write this. So you'll get some examples also. This documentation is pretty handy. So it's not mandated to remember all the available hyperparameters, available arguments which can be passed for each of my graph. It's rather you can be smart and see what is purposeful to you in terms of the usages. Okay, great. So again, interestingly, what we can do is we can also reverse the order of my graph. So instead of vertical plot, we can pretty much convert into a horizontal plot also. So we can just give a hyperparameter again orient. So instead of in orient, if we give as h, so nothing but as horizontal, the same graph will now be converted into, so the bars instead of being plotted on the vertical lines, it will now be plotted on the horizontal line. Okay, so that's pretty much again one extra thing which you can do on top of my bar plot. Guys, quickly, are you able to get this, or is it too much of an information? So I'll stop it here. So I think pretty much we have covered a good number of topics. But again, I want to understand if you are able to understand what we are talking here. I hope you are getting it right. So it's not going over the board. Guys, it's always important for you to understand it. There's no, again, as I've always been saying, so there's no benefit of me coming here and simply talking and going away. So it's important for you to understand. Just quickly tell me yes or no if you're able to understand the concepts or not. Any questions, anything so far, whatever we have discussed. So these graphs are pretty standard graphs. So Violin plot, bar plot, box plot, these are very standard plots. Okay, these are very oftenly used in terms of how we can use it in terms of our day-to-day purpose, right? Great. Thank you so much, Vasanta, for confirming. Anybody is having any other challenges from this? Or can somebody tell me, Vasanta, can you tell me how will you infer these graphs? Can you tell me one basic inference of what you can see from this this graph? Any inference which you want to write down, which you see from this graph? Anything which you want to talk about, guys? So anything which you see from this? So this is the last graph. So orient is equal to h. So in this one, do you see any interesting difference? So I would say pretty much the similar thing, right? So I don't see a very clear distinction between my embark town and the age. So very simple thing kind of the data. So it's not very distinctive. So it's almost similar. Rather, we'll try to see maybe fare. So instead of embark age, I'll try to see how the fare is. So maybe PLT.show is not fine. We'll see what is PLT. Fine. Anyway. So yes, now here we could see that the fare for Queenstown compared to my Cherbourg and Southampton is comparatively very less, right? So now we could see some clear distinction, but in terms of age, there was no such clear distinction, right? So likewise, we have enough number of things, guys. So don't worry about all of these. So we'll cover other plots as well. But I think you are able to understand what we try to do today, right? Great. So with this, I'll take a break, guys. So I'll meet you again tomorrow, same time, 10 p.m. and I'll try to cover the remainder of my graphs. I'll try to finish Seaborn tomorrow so that we can take a break for day after tomorrow for the occasion of Holi. And then maybe we can meet again on Saturday onwards, and then we can start with pandas. Okay, so that's what will be the agenda. But again, guys, as always, as a reminder, I want to tell you that so we are starting a data science live series from 9th of April. So that is pretty much a live course on data science, right? So it's a very standard course where the course structure is pretty much defined, and we'll be running that course for 10 weekends. So that'll be running for 20 odd classes. So every Saturday and Sunday we'll be going live for 2 to 3 hours dedicatedly for design topics every weekday, every class. Okay, so please do not forget to go to the website and check out Data Science Live, which is going to be happening from 9th of April, pretty much a live session on data science, right? And I'll be the one taking you through to the course, and that's pretty much the agenda, guys. So do not forget to forget to go through that course and see how we can cover up the things. Cool, guys. So with this, I'll take my pause, and then I'll see you tomorrow, same time, 10 p.m. and then we'll finish Seaborn tomorrow. Thank you so much, guys. Bye bye. Happy learning.